Hi, and welcome back to another stream. It's a lazy Saturday today, so I decided to take it easy, learn a bit, program a bit, read some articles. I won't go overboard with it, so I'm gonna try keep it as chill as possible, which is also the title of the stream. Hope you like my new uh screensaver wallpaper. Actually, no idea why I put it. I just like the suburbs, and now the American suburbs. It is. I'm not from the USA, so for me, I'm probably romanticizing it a bit, which probably isn't true. But what can you what can you do? So, uh, let me start this. Okay. So I'm just gonna turn this off for now. So, so. We finished the chapter on functions, and to be honest, when it comes to this project, I'm growing a bit bored of it. Uh, but I'll stick to it. I'll finish it and I'll finish it and start something new. So this chapter will be on conditionals. So let me just copy. Actually, let me see. How can I copy a folder in Linux with all the content inside? I think it's most probably cp/r. Yeah. Is this slash? This is not slash. This is to copy a folder along with all its contents. You can use the copy command with the recursive option. How do you call this? Is it a slash? It's not a slash. It's a dash. Hyphen or dash. Okay, that's the slash and that's the backslash. Good thing to remember. Copy chapter 12. Copy recursively. Make directory chapter 13. Copy recursively from chapter 12 to chapter 13. How to I made a mess. I should have copied the contents of chapter 12 and not the chapter 12. Okay, how to unpack a folder inside another folder in Linux? Removing the folder itself. Maybe how to copy the contents to move the contents of a folder, yeah, into its parent directory or another directory while removing the original folder. Can use the following command. Move. Yes, I just need to move the contents. Move chapter 12, everything inside here. Chapter 12, there's nothing there. I can remove it. Okay. What do we have here now? What do we have here now is all of this. So this chapter is called conditionals. Okay. I'm also gonna remove the functions executable. I'm gonna rename functions into conditionals. And I think that's it. So let's start with this chapter. Okay, so what will we do now is add conditional support in our Lisp project. We already added S expressions, unpacking, we have some built-in methods. We have, of course, in the beginning, we created our natural language processing in which we tokenize our inputs, blah, blah, blah. We did functions in the last couple of episodes. So now we're going to start with conditionals. So what should we do is that we're going to create a couple of built-in functions to deal with flow control and comparisons. Now Vim conditionals. What's this? How do I open a new? Okay, so it seems like Neovin doesn't let me open terminators. Right click drop down inside of it, so but I hate this. I tried fixing this a couple of times. Okay. Inside terminator. A terminal alternative for Ubuntu. I have a profile that I've been using. The issue I'm encountering is that every time I split my terminator window into multiple views, this is the default one. The new view gets resetted to the default profile, but I want it to keep the profile I already have. How do I do this? I like ChatGPT because it saves a lot of time on researching issues that I would usually encounter. Also because it pulls data from highly respectable sources. More or less you will find answers that you need. Like in this case, set your custom profile as default, open terminator. Profiles set as default. But how do I do this? I don't. What the fuck? Profiles, themes, layouts, preferences. It's here. Profiles. It's Dracula. Where is set as default? Where is set as default, man? Colors, title bar, compatibility, scrolling. The colors. No. The commands. No. In the preferences. Button found. Force new splits to use the current profile change. Layout. I also tried this. I tried all of this. Yeah, it seems I might have oversimplified. Yeah, you did. Okay, let me leave this to generate. I'm just gonna get a glass of water. Be right back. Alrighty, I'm back. So, your custom steps to ensure your custom profile is applied to all new splits. Open Terminator preferences. In Terminator, right-click anywhere in the terminal. Set preferences. Set your custom profile as default in the config file. Your custom. Okay. Okay, let's do this. Global. Wait. How do I search for shit? No. Ah, it's here. Global config. Default profile. Default. I don't have it. Dracula. So global config default profile. If this breaks, default profile Dracula. Save. Leave. Reopen. Split. No, man. I need to restart. I have. Yeah, I doubt it will work. So here's my default profile. It's called Dracula, right? It is. What have I done, man? What have I done? Okay. Preferences, profiles, layout, Dracula. So if I go preferences, layouts, oh shit. Horizontal split, Dracula, Dracula, close, don't send. Let's open it again. But it opens too by default, oh god. If I close, if I split, yeah. Ah, fuck. No. Okay, now not only does it open it on default, it's... How do I remove this horizontal split? Add new layout. I don't want this. How can I remove this? Close. Move. Why? What's happening here? Preferences. How do I remove this? Okay, I messed something up. Can I put this one as default? Save. How do I remove this? Prepare for it to explode. Oh, I managed to. Why? Ah, okay, save. Okay, I don't care. I'm gonna do this by hand. Terminator. I don't care. Profiles, Dracula. So, let's go to the projects. Let's go to the build your own Lisp, chapter 13. And let's start this work on conditionals. So what will we do? We're going to implement some comparison and ordering into the Lisp language that we are having here. We are going to have some built-in functions for greater than, less than, equal to, all the other comparison operators in C. Maybe an if function. Okay, let's do this. So what can we do as the first step here? What can we do? Actually, the first thing that the first requirement that we will need to do is to make truthy and falsy values. So we're gonna have the number 0, which is gonna represent a falsy value, and any number that isn't 0 will evaluate to true in an if statement. Hi. So what are we gonna do is we are making conditional statements in the Lisp language that we are writing, like the if blocks and comparisons. For simplicity, I'm going to use. Sorry, I always forget that I have that I have the stream running. I always forget that. Okay, so let's make a rule. Any number that isn't 0 will evaluate to true. 0 will always evaluate false. Okay, so we're gonna create some built-in methods. Where are they? Where am I keeping my built-in methods? Built-in head, okay, it's here somewhere. Built-in join, built-in add. Okay, I think I'm gonna put them here. I'm gonna put them here. I'm having the built-in greater than. I'm providing the environment. I'm providing our Lisp value. So what? Let us think about the logical here. What do I want to do? I want to compare different values. I want to return a number that's either 0 or 1, depending on the equality comparison between the two input Lisp values. Okay, so we'll have greater than. We will have, let me select 3 lines. I'm gonna paste them here. This won't be greater than, this will be less than, right? The next one, let me just move this down. The next one will be greater than, less than, greater equal, less equal, greater equal, paste another one. Less equal. Okay. But the problem now is all of these should use a reusable function, and we're gonna call this function built-in order. So what will this guy provide here? What will this guy provide? The environment, the Lisp value that we are working on, and wait, it's only one Lisp value. Just a second. Let me open my tablet here. So how will this work? We're gonna have a Lisp value, but what will it consist of? It will have probably 2 children, right? 0 and 1, and it's gonna be a Lisp value of type number. So this guy will most probably, the parent will be of type expression. I really okay, so it should be like this. It should be like this. What else do we need? No. I'm gonna provide the operator. I'm gonna provide the operator. Now let me search for some of my assertions. I forgot how they worked. So assertion on type is taking the arguments, it's taking the element, it's taking the expected element, it's taking the function. So it's gonna assert that this argument should be expected. Otherwise, I'm gonna get an error. Wait, I forgot how this works. How this work? So arguments, element expected. Okay, the arguments is the element that we are checking our condition upon. So this is our argument. We are comparing element with expected in order to make sure we are working on the correct element. And this is the error message. Type error got. What is the function doing here? I think the function is just the name of a function. It's not a reference on a function. Is the name like equals or def or something like this. And this is what I got. This is what I expect. Okay. So this is how a assert type works. Built-in order. Let me also see how I implemented it. Yeah. So I'm working on an element. I'm checking to see if the first element of the element, the first element of the Lisp value is of a certain type. If not, please print the message, and the error message, and the tail here just tells us and gives us more information on what kind of error are we expecting. Okay. Built-in order. Okay. So first things first. What have I done here? Built-in order. It's here. Type. A is a Lisp type. I want to make sure that the first element of A is some number. And I want to provide a function as well. And the function will be an operator. Same thing here. A, I want to make sure this time that the second element is of type number. Why? Because we will compare these guys. We will compare these guys with these built-in methods: greater than, less than, greater, equal, less equal. So another one, we need to make sure that the count of elements here is 2. Otherwise do this. Okay. So we're gonna have a return value, and now if string compare without r of the operator is a greater sign, and if we encounter this one in this method, r will be first element is greater than the second element. Cool. Now we just need to repeat this 3 more times for every comparison. Three more times for every comparison. Okay. Let's do this. I'm gonna select this in Vim. So in Vim I can select multiple lines with writing down the number. It's here. It's 3, and then I'm using. Oh, sorry. I need to. So it's 3, and then I'm using the jank command 2 times, which basically copies it to the clipboard. And now I can just I can have my cursor here, and I can just paste them. Oops, paste 1, paste 1, paste 2, sorry, and paste 3. Now we need to individually change them. This line is an extra. So if this is less than, I should compare. Where are you? You are here. I should compare this like this. If we have entered, wait. In Vim, no Vim, how to search? But I already know how to search. It's like bum, bum, bum. Yes, I'm here. So if this is greater than, we are putting the greater than sign here. Now if this is I like both Vim and Melvin, but I feel like I can't control them properly anymore. Because look at this, I move the keyword up, so it's starting here. So now when I press down, I expect it to come before the if, but for some reason it moves to this place for some reason. Less than, let's see. And I think that's it. The last thing that we need to do is delete this Lisp value and convert the number that we have here that we set to the comparison of all of these combinations. We're going to return it, and we're going to create a new Lisp value out of it. Okay. Why is this selected? Why is this selected? Okay, here built-in order EA this this save. Okay, so we have our comparison methods for numerical types. So they can be bigger, greater than, lesser than, greater, equal, or lesser equal. If you notice that we are missing a pretty big piece of the puzzle, you're right, because you're missing the equal sign, the equality method. So let's do this here. So the thing with equality is that it's going to be different than ordering, because here we are comparing numerical types. With equality, we want for the equality to work on more than just numerical types. We can have complex structures. We can have comparisons to an empty list, or even we can compare functions itself. So based on this, we need to create a function that will test equality between different types of list values. And we're going to create one function that will check whether, so, and the only way how we can compare this is by looking at the elements itself. For example, if we have a co-expression which has these contents, and another one that has the same contents, these are, from a standpoint of memory addresses, not the same. I don't know, this could be A, B, C, E, no idea, E, E. But this one, A, B, C, F1, no idea. So in order to check properly whether these consist of same elements and whether the equality operator works on them, we need to compare them element by element. Let's continue. So what's the type of this one? It's going to be a number, whether it's equal, whether one Lisp value is equal to another one. So if okay, so wait. Where are you? You are here. So what could happen here is that the LWell, it's too small. The LWell object is consisting of a lot of different properties. One of them is the type. So we can compare the two values A and B based on the type. If they don't have the same type, they're not equal, right? We can compare two Lisp values of different types. We can compare numbers with symbols. It just doesn't work. This. Just check something, please. Okay, so how can we compare this? First things first. If type of X is not equal to type of Y, I'm returning a 0. Not equal, straight ahead, not equal. Now, let's base it on type of X, because we already checked that type of X is equal to type of 0. We can only put one of these here. And now I can do this on case level. I can do this for numbers. And I'm gonna return, what am I gonna return? What am I gonna return here? Yeah, X number equals epsilon number. Let me just check something. I want to see if I have written the case properly. I think this is okay. So go back. Built-in LWell equal what? LWell equal it's here. This is the number. Case symbol. Symbols work differently in C. Here we need to compare them based on the string contents or on the character contents. So also it's going to be the same thing for errors. So no, actually it won't be the same thing for errors. So for symbols, we're going to have string compare of the X symbol, of the epsilon symbol, if it's 0, maybe I should do something like this here. I don't know if this is, I don't know if this is right or correct. the syntax, I think. So for errors, we're gonna do the same. Ah, I hate. I misclick something and suddenly it's like when you move a picture in Word. Okay, this was the easy part. Now, let's think of functions. So for functions, we have two cases. We have two cases. I hate this. I hate this. I was clicking it. Built-in. Built-in. No. 55. So what's built-in? Built-in is a built-in method, and what does it consist of? Where is it? Ah, it's here. So it's a function that has the return type of hello, takes a built. Let me. How do I how to copy contents inside mail vim to paste in an external clipboard. Okay. Plus yank. So this means access register plus yank. Please explain me this type def in C. Let's break down the following type def declaration C step by step. So we have this snippet of code. This declaration introduces a new type named lbuiltin. It looks complex at first glance, so let's analyze it in parts. So type def in C is used to create an alias for a type. Type def in C used to create an alias for a type. This is the return type. The function this pointer refers to returns to a pointer to lval. This is the function pointer. Wait. A type def in C. So typedef in this simpler case will take this struct ll and will alias it to only ll. So this will actually take all of this and create an alias for only L built-in, I assume. This is the return type. Why is this a function pointer? The built-in indicates that built-in is the alias for a function pointer type. The parenthesis pointer to a function. So I understand the logic behind taking the arguments and the return values, but why do we take, why? So this is how we can use this. Wait. So start the new chapter. I already started it, but how does this work? Okay, so I need to go really quickly. So I unfortunately need to leave this half done, but I'm gonna continue working on this. But what I want to do is I want to understand how this works. This whole typedef. So basic structure of the type. I know what typedef does. It creates an alias in a sense. Basically, you don't need to write complex struct definitions. You can just prepend them with typedef, and everything that you write will be used as an alternative name for whatever you created, like in this case, or in the case that you just seen. But this is what I'm interested in. What does this mean? Please explain. I love how I always ask ChatGPT nicely to explain. So the function this pointer refers to returns a pointer to ll, a pointer to ll. Function pointers can be tricky to read and manage, especially when passed. Okay, so maybe the requirement for this is the way C handles functions under the hood, and the way it passes functions around. It needs to pass them by reference in order to use them in different functions. So at its core, this syntax creating a function pointer type. Okay, I know this. It's creating this in the end. All of the letters around are just fluff. This is what is returned, the built-in keyboard. What's a function pointer? A function pointer is a pointer that holds the address of a function. Just like how a regular pointer stores the address of a variable, a function pointer stores the address of a function. This allows us to pass functions around. Just like variables, which is useful for callbacks, dynamic dispatch, and other advanced program techniques. This is a type def that gives a name, this name, to a specific type of function pointer. This part means that this L built-in is a pointer to a function. I know this. The parentheses are necessary to ensure grouping. Okay. Syntax related thingies. If you wrote it as this, it will be incorrectly interpreted as a function returning a pointer rather than a pointer to a function. Without the parentheses, the meaning would be different. This declares a function named L built-in that returns an L. And this declares L built-in as a pointer to a function that returns. Okay. So it should point to any function that matches the signature. Why use a type def for function pointers? Function pointers can be hard to read and work with. For example, without a type def, every time you declare a function pointer, you need to write this. By using type def, you can now declare function pointers pretty much easily. And how does it work in practice? A function matching the built-in signature. So this is this function that does this. It takes these inputs, the environment and the value. It returns the value, some logic. It returns the value. And here I'm creating it. So I'm referencing it without the need of providing. I'm only referencing the address of it. I'm pointing to the contents of it in memory, and then I could most probably provide values and parameters at a later stage, right? Function, yeah. So I can use this here. I can move it around. I can provide it to different methods and stuff. Okay, interesting. Oh, 3 people are watching this. Sorry, I need to go. Yeah. Yes, suddenly I got 3 people watching, but I need to go. I'm gonna continue. I'm gonna create a new stream probably today. If not today, then tomorrow. And it's gonna be a longer one. Not 1 hour long streams. They should be longer, definitely. So thank you all for watching and see you the next